Thank you very much. So this is, of course, not only my work, but also the work of my wonderful co-authors, Caroline Busse, Katharina Pfeffer, Matthew Smith, and Emanuel von Setschwitz from SBA Research and Bonn University. So I would like to start my talk with a little throwback to 2014. Let's have a look at the internet ecosystem in 2014 and HTTPS in general. So this was the time when Heartbleed was discovered and all over Twitter, and everybody was going crazy about it. And yeah, at this time, about 75% of the websites on the internet was not really sufficiently secured, as you can see here. Well, I would say somehow that HTTPS is one of the security or even usable security success stories. So compared to 2014, today a much larger percentage of websites can be considered secure. Researchers have improved connection security indicators and improved click-through rates in warnings. So especially the Chrome team did a really awesome job on that. Also, Let's Encrypt and Certbot have simplified the deployment process. So for administrators, everything has become much easier these days. So the burden was removed, and in general, we can see that today there are much better configurations out there. But regardless of these efforts, about 30% of the websites are still not sufficiently secured. And what we wanted to know a couple of years ago was why this is actually the case. And why do we also still have so many vulnerable configurations, although we now have Let's Encrypt and Certbot and everything is fine, isn't it? So what we did is we published this paper at Usenix Security in 2017, and we conducted a lab study with knowledgeable experts and let them configure HTTPS. Well, our results indicate that the security assessment of the configurations that resulted from the lab study looked actually quite promising, but not much better than in the real world, actually. But the point here is not the grade that we gave to all these configurations, but more the qualitative statements that the administrators gave to us. Because what they said basically is, oh, great that my configuration is secure now. Good, I found the right tutorial. I have actually no idea what I'm doing here. I have no idea what these cipher suites actually mean and what they're used for in my configuration. But hey, this tutorial works for me. And this is why they had quite good configurations. But what the study clearly shows is that many of these administrators had no idea what they were actually doing. So we thought to find out why this whole confusion is there, we dig a little deeper and perform a qualitative study on mental models of HTTPS. So what is a mental model? A mental model is basically a mental representation of the surrounding world or a piece of technology that we interact with. And of course, these mental models are very much shaped by our experience. So for example, I have a good mental model of a water bottle, because I have experience in opening so many water bottles. So I know what I have to do in order to make it work. But not only experience contributes to the shaping of these mental models, but also design contributes. And this is a thing that I would really like to raise awareness for in our community, that every piece of technology that we build, no matter if it is something that end users interact with or maybe administrators that use these configuration options or programmers that use APIs, all these interfaces help shape these mental models and very often shape incomplete mental models or simply wrong mental models. So what we did here to measure these mental models is we, of course, did extensive pre-testing to come up with a measurement instrument to then finally get these mental models. We then recruited participants, gave them a questionnaire for demographic informations, to ask them about how they use HTTPS, whether they have configured it before, whether they have written TLS-related code, and so on and so forth. And then we conducted semi-structured interviews, including 3 drawing exercises. Then afterwards, we did some qualitative coding as we borrow from social sciences, and then we did a post-hoc validity study to make sure that our instrument was really valid. So the interview guideline looked as follows. So our interviews consisted of some general questions about usage behavior, browsing behavior, and security expectations when interacting with browsers. Then we had 3 drawing tasks. So the first one was, can you please describe and draw how encryption works in general? The second was, imagine you want to buy something at your favorite online shop, and this online shop has this green lock or is accessible with HTTPS. Can you please draw what's happening between you and the online shop? And the third one was online banking with HTTPS. So a rather similar scenario, but again, helped users to think about how they think the system works and to elicit this tacit knowledge that they have. And the last part of the interview was about attacker models. So what attackers they think could eavesdrop these messages. So we did not only interview administrators, but we also interviewed end users because we also wanted to see the comparison between these 2 groups somehow. And it was very easy to reach saturation with administrators because they are rather homogeneous sample. And the cool thing here is that we had real administrators who were administrating service at real companies, small and medium-sized enterprises in Europe. So in the end, we had a data set of 30 interviews. We had a lot of quantitative and qualitative data. We had those drawings. We had the descriptions of the drawings and all the reasoning and the think aloud, which of course was transcribed, and we had some handwritten notes to analyze. And coding, well, this was, if you're familiar with qualitative methods, this is a quite standard approach here. So we had 2 rounds of open coding where we developed a code book. We had 3 independent coders who coded the data individually, and then we resolved conflicts and so on and so forth, and made these codes more fine-grained in order to have a better quality analysis. Then in the end, we used descriptive actual coding and selective coding. So let's have a look at these drawings, what these drawings look like. This drawing, what do you think? Do you think it was from an end user or from an administrator? Who thinks it was from an end user? Thank you. Well, it's actually not. It's a drawing from an administrator. This was an administrator at a real company, and well, this person gave us a quite nice description of how they think it works, but super, super, super sparse and super superficial. So we do not really think that this person has a good understanding of how HTTPS works. And yeah, this is a real administrator at a real company who has configured HTTPS before and clearly cannot tell how it really works. What we can also see here is that analyzing these drawings is really, really difficult because without any audio description of this drawing, it's impossible to really analyze such a drawing. So what we really did when we started our initial coding process was one assistant read the statement from the transcript aloud, and we looked at the drawing simultaneously and then coded the contextual statements in light of these drawings. So let me give you another example. This is another really nice example, I think. This is a drawing from an end user. And what we clearly see here is that this part here indicates, well, this is what you cannot see here, but what is also from the audio track. This is unencrypted traffic, and this then gets forwarded to a centralized encryption component, which encrypts everything and then sends it to Amazon, which is the online shop of the choice here. So we can here see this is a really sparse mental model, and this mental model clearly assumes that there is a centralized encryption entity that does all the crypto stuff. So the connection between the end user and the encryption component is not secured, and this is a potential attack surface for an attacker. This, I think, is a very interesting model as well, because this drawing shows, well, yeah, here again, we have the home computer, we have the online shop, but what we can clearly see here is that the concept of transport layer security is quite well understood because attackers cannot read messages here from this protected channel. And also this end user correctly indicated that the vulnerable points, which you can see here in red, are actually the communication endpoints. So what I really like about this model, this was an end user, somebody who was not really familiar with the underlying technology, but still had a rather sparse but kind of correct mental model in their head. This example is from an administrator, actually. And I would say that this is one of the best case scenarios. This is actually an outlier. So this is completely different to all the other drawings that we saw. We can see that this is quite accurate. It contains various components, various messages going around. The audio track was huge. This interview lasted for a very long time. And this administrator was actually very good at describing how HTTPS works. But yeah, also with, of course, some limitations. So after all these different stages of coding, well, we really tried to make sense of everything and come up with two rather abstract models that combine all the findings all together. And we ended up then with two models, one worst case mental model and one best case mental model here. Yeah, so let's have a look at the worst case model. Well, this worst case model clearly again here has this centralized encryption component somewhere where messages are sent in plain text to, then encrypted and then forwarded to the online shopping site or the bank respectively. And the assumed attacker model here is actually that intelligence agency, ad trackers, hackers, anyone who is bad in general can access this centralized encryption entity. Also cookies, here as a gingerbread cookie, are bad and can access different types of information. We have no connection security indicators whatsoever here. Those are not really part of these mental models. We also do not have the notion of EV certificates, for example. And what is particularly interesting here is that this worst case model makes a difference between the two drawing exercises, actually. So they say that, well, online shopping sites do not have such strict security requirements, and therefore one code is sent together with a plain text message. This code is then used by the HTTPS proxy to encrypt, and then, yeah, this encrypted message is sent to the online shopping site. But for banking applications, a certain amount of users thinks that the second factor that is very often used, well, two-factor authentication is very normal, of course, in Europe as well. So they think that this secondary factor is used for encryption, and it adds an additional layer of encryption to, yeah, the other encrypted part, and then is transferred to the bank. So what we can clearly see here at this worst case model that authentication, encryption, security is perceived as kind of the same, and those concepts are much more mixed, and yeah, this secondary factor is assumed to be used for encryption as well. A good thing, according to our data, is that these parts of the worst case mental model are actually specific for end users. So none of the administrators assumed such a centralized HTTPS proxy, luckily. So now let's have a look at the best case model. Well, the best case model, of course, has so many good aspects, but some aspects that I think are particularly worrisome, especially as we have a sample consisting of knowledgeable administrators who were administrating server at real companies. So the good thing is that this best case model has this protected channel somehow where attackers cannot eavesdrop messages from. So this concept is quite well understood. Very few participants had those connection security indicators in their mental model. So this was really the best case. But again here, nobody thought about EV or anything comparable. The best case model also consists of a CA. But what is important here is that the role of the CA is not really well understood. So nobody really knows what the role of the CA is in the ecosystem and why certificates are needed for, and concepts like server authentication are not really most administrators were not even able to explain what this is used for. Also, what was very specific to administrators is that administrators like to play around with buzzwords. So they were throwing in buzzwords and some protocol components, but they were not really able to explain what these buzzwords meant when we asked them. And we asked them, and we really asked them a lot of follow-up questions, and most of them were really not able to explain what this means. So all this is kind of disconnected, and the model is not really conceptual. Yeah, So what do these findings mean now in the end? Well, actually, we managed to reveal some misconceptions about the security benefits and the threat models from both groups. What I think is a really good thing that we observed is that end users, actually quite a high number of end users that we interviewed, were aware that their endpoints are somehow vulnerable components and that they are responsible to make sure that the endpoints are secured. And administrator, in general, assumed more sophisticated attacker, which we also think is a really good thing because this is what they are in charge of and what they should be aware of and control. Yeah, we also identified protocol components that interfere with secure configurations and usage behavior. So some protocol components are really not well understood. And the interesting point here is that administrator mental models are very much protocol-driven and not so much conceptual. Yeah. And our results also suggest that end-user mental models are more conceptual, less protocol-based, and end users often confuse encryption with authentication, which I think is quite worrisome. Users also distrust security indicators, so both administrators and end users often said that those security indicators are only there for marketing and they don't really mean that much. Yeah, and with this, well, there are many other interesting aspects as part of the paper. So for example, I completely left out the part on mental models of message encryption and the more detailed findings on attacker models and security expectations of the protocol. I would also like to say that my research group at CISPA is currently hiring, so I'm always looking for talented students that want to work in this domain. And by saying this, thank you very much, and I'm taking questions now.
Thank you, Katharina. And I think we have a question lined up back there already. Just one quick thing before that. If the next speaker does not have a microphone yet, please pick it up in the back. Otherwise, please go ahead.
Paul Van Oorschot, Carleton University. Thank you for the talk. Very well delivered. I guess it's less important if a mental model is correct or not than whether it supports user actions which help or hurt security. So do you have any specific examples of how the mental models helped or hurt security?
How they help or hurt security? Well, I think in some sense they hurt security in a way that, for example, Let's Encrypt abstracts so much of the configuration process away from administrators. But what it does not remove is the retrieval of the certificates, for example. But as we can see, if the role of the certificate for the entire ecosystem is not clear, I don't know if this is a good idea to take this away from administrators. I totally agree with you. I think the major point is that here is that we don't yet know. I mean, I think this is something that we should further study, how these mental models impact behavior then.
Hi, Phoebe Rouge from the Federal Trade Commission, and I guess sort of following on with that, I'm curious sort of what would you think about, so like from some of the other talks, it seems like a lot of the effort in getting HTTPS properly configured is sort of pushing things on the infrastructure side or the browser side so that it's pulled away from the individual administrators and the users because it's complicated and people don't understand it that well. But do you think that that's the right focus, or is it sort of, you know, we should focus more on like educating people on how to use, you know, what this really, how this works, or is it more like, where would you think that effort should be concentrated in that?
I think that's a very interesting question, and to be honest, I thought a lot about this. So I think that, yeah, pushing more on the infrastructure side, I think is a good thing. But I also think that this study clearly shows that we often implicitly assume that people, especially knowledgeable users, are experts. And what we see here is that, yeah, very often they just copy stuff from the internet and they are not really capable of making informed security decisions here. So I think we overestimated the knowledge of these administrators a lot. So I think what we need is to actually design the technology that they interact with in a way that it's easier for them to make these security decisions. So maybe just abstracting everything away from them is not the right way to go. We need to abstract away the right things, the right components. And I think that this is not what our community currently does. And yeah, this again is very important to me to say that every API, every protocol that we in this community built has an impact on these mental models. So we are the ones who help constructing these mental models. And we need to make those decisions when we design those protocols.
Thank you.
Are there no further questions anymore? I don't see them. With that said, thank you very much, Katharina.
Thank you.